So I have shared my screen. I hope you people can able to see that. So let us start with today's class. So yesterday we were discussing about performance tuning. We started with the point where we understood about two types of tunings are available. One is proactive tuning and the next one is reactive tuning. And the proactive tuning, as I said, we need to start from the scratch whenever you are creating the database. And the reactive tuning you need to handle whenever you face some issue, like one query is running slow, or database performance is going bad, etc. So for that we have different phases in tuning. So starting with the first one we saw is network tuning, in which we need to identify whether there is any network impact or is there on the database connections. Because whenever the whenever the network connection is bad, then obviously the database queries, etc. will run slow. So we need to identify the cause for that, and if not, we need to go ahead with the next phase, that is application tuning. And in application tuning, we are going to verify with the application team or the developers whether they have modified any code in the applications, like whether they have added any extra lines of code or whether they have deleted any lines of code. So we need to basically verify about that. And if not, we need to proceed to the next phase, that is SQL tuning. And in SQL tuning, we need to identify what are all the bad queries that are giving problem to the database. And for that, we have different reports like ADDM, ASH, etc. So more about these reports we will be looking in the next coming phases. And also in SQL tuning, we need to identify whether the existing form of SQL query is fine, or do we need to rewrite the SQL query in a different format. Because for one requirement, as I said, there will be multiple forms of SQL queries. So we need to identify what form will be suitable for our requirements. And also, as I said, from 10G onwards, we have a new feature called SQL Tuning Advisor, which is going to give you the recommendations like what or which line to tune or which particular join you should delete. So all those kind of information. And then we looked into object tuning. So where the first subtopic we understood is analyzing the table or gathering the statistics. So basically, the statistics of the table are nothing but the information about the table, like how many rows are there in the table, and how many blocks this table was occupied, and what is the size of the table, and how many null columns are there inside the table. So all this kind of information we call it as statistics of the table. Now usually what happens is, if the statistics are not up to date, then there is a chance that optimizer is going to generate a worst execution plan. And whenever optimizer generates such kind of plan, obviously the query also will be executing long time, and which will impact the performance. So instead of that, if we want everything to be perfect, then we need to make sure that for every table the statistics are gathered to the latest date. And for that we have a query which we saw, like through which we can identify what is the last analyzed date of the table. And if we observe that the last analyzed date of the table is a older one, then we need to manually collect the statistics. But we need to do this activity during non-peak hours of the server time. So usually it will be done in the night time of the server, because collecting the statistics will go and verify each and every row. And if your table size is very large, then it is going to take quite a long time. And we saw some commands. What commands we need to use till 8i, and what are the new commands we have in 9i, and what are the different levels of statistics collection also. Like we can collect the statistics at table level, index level, then schema level, database level, and even we can collect the statistics for base tables also. We saw all those commands, and we understood one point that 10G by default comes with an automated job which is going to collect the statistics of the database and or the tables which are modified greater than 10%. But as I said, some practical complications are involved, so it is better to avoid that automated job, and we need to schedule our own jobs. And for that we need to understand we cannot collect the statistics of entire database overnight or in a single day. So that's the reason we usually divide our tables into three categories. One we call it as static, and the second one semi-dynamic, and the third one is dynamic. So as you are seeing on the screen right now, for static tables we need to go for monthly analyze, semi-dynamic we need to go for weekly analyze, and for dynamic we need to go for daily analyze. So till this point we have been discussing yesterday. So now let us go and look into the other points regarding the optimizer. So basically optimizer, as you know, is a set of algorithms. So these algorithms will work together, and they will conclude on the generation of execution plan. So these optimizers usually work on two algorithms. One we call it as rule based optimization, shortly we call it as RBO, and this particular RBO algorithm has been removed from 10G onwards. So deprecated means removed. And the second optimizer that we have is cost based optimizer. So now first we need to understand what is the difference between these optimizers, what is RBO and what is CBO. So rule based optimization is something like a flow chart. I hope everybody of you might have known about flow chart, in which case there will be some directions. So if this condition is satisfied, there will be two things, like yes, you will be moving to one direction, and no, you will be moving to another direction. So again, if you get second condition, again you will go through yes or no situations. So that means whatever the rule that you have defined, you are completely following those rules only. So when this rule based optimization algorithm is there in the 8i versions and 9i versions, what used to happen is Oracle used to blindly follow some rules, and never it can take its own decisions. Like optimizer will follow just the rules which are defined in RBO algorithm, but optimizer never used to think on its own whether this is a correct path or not. So because of this, sometimes it is fine, but some other times it may not be a good one to follow these kind of rules. So for example, I'm just taking some example. Let's say you want to travel from A to B and then B to C. Let's say this is the rule that is defined, and when you submit this kind of rule based optimization to optimizer, then even though it is a time taking process, strictly it will follow from A to B, then B to C only. And suppose there is a chance that without touching B, A can directly go to D, and from D it can come down to C. So even though there is another alternative path which is much more beneficial, even then optimizer is not going to take that particular route, and it is going to stick to A to B and then B to C only. So because that is the rule defined. So because of this, most of the times people observe that there is a performance issue, or optimizer is not generating the expected best execution plans. All these complaints were coming into Oracle Corporation, and Oracle started working on this, and gradually they have come up with another set of algorithm, but that is cost based optimization. So in this cost-based optimization, the enhancement is optimizer, after generating the execution plan, it can think whether this plan will be suitable for my query execution or not. So some intelligence was attached to this algorithm, so that optimizer can think of whether this will be suitable and whether it will give the response within the expected time or not. So it can calculate all those things. So that is the reason cost-based optimization was made mandatory from 10G onwards, and Oracle even chooses to use cost-based optimization in 9A also. So that is the major difference between rule-based optimization and cost-based optimization. As point number 7 says, CBO and RBO are the internal algorithms based on which the optimizer is going to generate execution plans. And how we need to specify whether my database is using CBO or RBO, it depends on a parameter which is mentioned in point number 8, that is optimizer underscore mode. So if you say optimizer underscore mode equals to RBO, then it is going to use rule based optimization algorithm. And if you say optimizer mode is equals to CBO, then it is going to use cost based optimization. And we have some other options also, like optimizer underscore mode equals to choose, CHOOSE. So when you say choose, then you are leaving the chance to Oracle, and Oracle will decide whether it need to go for RBO or whether it need to go for CBO. So all this used to happen in the 9A and before 9A versions, and from 10G onwards we don't have any choice to use RBO. So compulsory you need to go for cost based optimization only. So that's the reason when you go for optimizer mode in 10G, then it is going to show you something like all underscore rows. So let me show you that. So if you want to know the value of optimizer underscore mode, then you are going to use this command show parameter optimizer underscore mode. So it is going to give you the value as all underscore rows, which means that you are going to, or which means that whatever the number of rows that the user is asking, then using this cost based optimization algorithm, optimizer need to give all the rows. So if user is asking for 100 rows, then optimizer need to generate an execution plan which can able to retrieve all the 100 rows. So it is what basically means by all underscore rows. And apart from all underscore rows, we have another option also, that is first underscore n underscore rows. So you can see here in point number 10. So apart from all underscore rows, we can define optimizer underscore mode equals to first underscore n underscore rows, where n is some integer like n equals to 10 or 20 or 25, 100, any value that you can give. So basically what is mean by this? For example, if I say first underscore 10 underscore rows, that means even though user is asking for 100 rows, then Oracle is going to display only the first 10 rows on the screen. So that is what it means by first underscore n underscore rows. For example, if you say first underscore 100 underscore rows, then even though user is asking for 500 rows, then it is going to display only the first 100 rows. Now you may get a doubt like if user is asking for 500 rows, then why I need to restrict to display only 100 rows? And this is very popular in many of the websites, and one such usage is there from Google also. So when you go to Google and type something, let's say you are searching for something, uh, let's say you type something like how to install Oracle 12c. Now if you scroll down at the end of the page, you would be seeing that, or sorry, at the beginning of the page, here you can see a message which says it has retrieved 5,92,000 results. So in just 0.38 seconds, Google has retrieved you 5,92,000 results. But is those 5,92,000 results are displaying in the same screen? No. Out of those many lakhs of results, Google is going to display only the first 10 results. So as you can see here, the first 10 results are being displayed, or the first 10 websites information are being displayed on the screen. And if you want to go for the next set of 10, then here at the end of the page, you will be having page 2, page 3 till page 10. So you need to click on this page number 2. So like if you can't able to find out your requesting information in page number 2, then you need to travel to page number 3, 4, something like that. So like this you will be having the options. Now can you people tell me how many times you have gone, or you have, in a month when you are using Google, how many times you clicked on page number 2? Can anyone give me the count, like on an average in a month, how many times you clicked on this page number 2 when you are searching in Google? Yes, very few, or almost I can say negligible. So I mean, if at all we don't get the expected results in the first page itself, then we will proceed to the next page. But if at all most of the times we will be getting the results in the first page itself, then we don't really require to go to second page. That means even though in my database to this search I have 5,92,000 results, but still out of those 5,92,000 results, if I can able to get my information in the first 10 rows itself, then it is not required for me to process the other 5,91,990 rows. It is unnecessary waste of time. So similar to this, what we have is first underscore n underscore rows. So if you say first underscore 10 underscore rows, and if your user can able to get his data, whatever the data user is expecting, if the data is being retrieved in the first 10 rows itself, then user don't require to go to next set of rows. So if user is asking for 500 rows, but the expected results is there within the 100 rows, then you don't require to retrieve the extra 400 rows. That means you are reducing some burden on the database. So in this kind of situations, you will be using this, first underscore n underscore rows. And this has been implemented by many websites. For example, nowadays shopping websites are also implementing this. Like in India, we have one shopping website by the name Flipkart.com. So if you go there and let's say you are browsing for something, let's say I am browsing for something like a smartphone, and if you look at here, totally it is saying that it is showing 552 products, but frankly, if you scroll down, it is not going to show you all the 552 products. It will show you only first 50 or 30. And when you keep on scrolling down, and once you reach the end of the page, then here you can see page 2 is appearing. So once you reach the end of page 2, then you will be observing page 3. So if you still scroll down, you can see a message, then page 4, then page 5, and at one point you can see you are getting a button where it says show more results. Like this, many a times you may get your expected result in the first page itself, or first 20 or 30 results itself. Then in such case, I don't require to retrieve the extra 500 rows for you. So which can reduce the burden on the database and improve the performance of the database. So that is where we have this option, first underscore n underscore rows. So is this point clear to everyone, or anyone is having any queries? Just let me know. Okay. So all this we are seeing in object tuning phase under this gathering statistics, and let's say even after having these statistics to the latest date and all, still if the performance problem is not yet resolved, then we need to go ahead with the next sub phase in object tuning itself, that is something called explain plan. So explain plan is nothing but the execution plan, and through this explain plan you are going to identify whether your statement is using indexes or not, and if it is using indexes, whether it is using the right type of index or not. So you are going to basically check all those things. Okay, we have a query. Do we need to retrieve specific rows? I didn't get you, Samir. What you mean by that? Can you frame your question once again? Yes, I mean when we are using first underscore n underscore rows, we are specifying only the first 10 rows or first 200 rows, something like that. Yes. So do you mean to say while gathering the statistics, do we need to specify that we want statistics are only on these many rows? No, we don't require to do that, because statistics collection we would be doing on entire table, not for the specific set of rows. So we don't require to specify anything like that. Okay. So let us look into this explain plan. So as point number 1 says, it is a plan which shows the flow of SQL execution. And to generate explain plan, the first requirement is we need to have something called plan underscore table and CC schema. And if at all that plan underscore table is not existing, then we need to execute a script which is residing in Oracle Home RDBMS admin, and the script name is utlxplan.sql. Most of the times by default plan underscore table will be there whenever you create the database. So here also you can see when I describe plan table, it is existing. So once you have plan underscore table, then you need to execute the steps which are there in point number 3. So the first one is granting the select and insert on this plan underscore table to the schema which is giving problem. So in my case, what I am assuming is, I am assuming select star from EMP is the query which is giving me the problem. So till yesterday this select star from EMP is used to give me data in 5 seconds, and today it is giving the data in 2 minutes or 3 minutes. So I am just analyzing that. So assume that is the query which is giving problem. So I am saying grant select comma insert on plan table to spot user. Then we need to disconnect from sys user and connect as a spot user. Okay, so it says the account is locked, no issues. Let me unlock that account. Okay. Sorry. So now that I have connected as a spot user, and now I need to execute a command explain plan for the statement which is giving the problem. So for example, in my case I am assuming the statement which is giving problem is select star from EMP, so I need to execute it. Then it is going to display an acknowledgement saying it is explained, and the explained plan information is going to be stored in plan underscore table. So to retrieve the information in a precise format, we need to execute a particular script, that is utlxpls.sql. So this script is going to pick up the information from plan table, and it is going to design it in a tabular format or understanding format. So you can able to see that here. So first it is going to give you plan hash value. So every execution plan will be having a unique identifier. This we discussed in the architecture class also. So that particular plan ID, so we usually call it as execution plan ID. So that plan ID is nothing but that value which is showing above, and then it is going to show you what exactly this query is doing. So first one, it is a select statement, and on which table it is going to do the select. It is on EMP table, and how many rows it is retrieving, 14 rows, and how many bytes or the size of the rows, it is 518 bytes, and how much percentage of CPU is being utilized, 3% of CPU, and the time it is taking is just 0.01 seconds. So this is hours, then minutes and seconds. So it's only 1 second that it is going to take to retrieve the data. And what is happening here is, it is going for table access full, or some people we call it as full table scan. So what is mean by full table scan is, you are going to read each and every row of the table. That means Oracle has passed through each and every row, and then it calculated or it retrieved the 14 rows. So, and here usually the question will come is, if we have an index on a table, then why Oracle is going and making use of full table scan? Because usually we know that if index is there on a table, then Oracle should use index. And here I am just showing you that. So if you look at okay, so it's I'm there in spot user. So if you look at here on EMP table, there is a index by the name pk underscore EMP. So my question here is, if the index is there on the table, then why table is not making use of that index, and why here it is showing as table access full or full table scan? Can anybody guess what could be the reason? Okay. So the reason is so simple. Here we are saying select star from EMP. That means star means you know already, which means you want complete data from the database. So or the table. So when you want complete data from the table, then why I require to go for index? For example, let us say I have a table. Index is just like normally if you somebody asks you what is an index, you will refer that to something like a book index. Suppose I want to take Xerox of entire book, then why I need to take care of or why I need to go for index? So if at all you want to take Xerox of complete book, then you don't require to look into index at all. Similarly, when you say select star from EMP, that means you want complete data from the table. When you want complete data from the table, then why you require to go and make use of index? There is no use. So when we will be using index, suppose out of complete book, you want specific chapter to be taken Xerox, then you would be going for this particular requirement. So similarly, out of these 14 rows, if you want to retrieve specific set of rows, then you would be using, this or Oracle would be using index. So let me show you that one also. So once again, I am connecting a spot here. And now I am using a different set of SQL query. So have a look here. So here what I did, I am earlier case I used, I said select star from EMP, so complete data was retrieved. But now I am strictly saying I want the employee numbers from the employee table, in which the department number 10 is there. So that means I don't want all the rows in the database. Now let us go through once again the execution plan or the explain plan and see whether it is using full table scan or whether it is using indexes this time. So if you look at here, it is still going for full table scan. And how many rows it is retrieving? 5 rows. You can see that over here. So that means to retrieve just 5 rows, it is scanning 14 rows. So that means unnecessarily it is scanning 9 rows extra, and which would be a burden to the database. So if we look at the smaller counts like 9, 14, 5 and all, it may be very small. But for example, let's take a scenario where you have 1 crore records, and out of 1 crore records you want to retrieve 10,000 rows. Then definitely, just to retrieve 10,000 rows, if you are scanning 1 crore rows, then it is really a foolish thing. So there is, some gap there that you can conclude it. So similarly here also, just to retrieve 5 rows, you are scanning 14 rows in total, which is an unnecessary task. Now fine, here what we need to understand is, okay, earlier case we asked for all the rows. That's the reason Oracle is not using index. But the next example, we have selected rows. But still why Oracle is going for full table scan? Why it has not used index this time? Because this, the column which we are using here and the column which was created on top of index are different. For example, there is a view called db underscore ind underscore columns, and for user you need to say user underscore ind underscore columns. So this will tell you on which columns the index got created. For example, I am taking this. So if you look at here, the index was created on a column called EMP number. But in the where condition, the column which you used is DEPT number. So do remember this point, it is very important. The column on which the index got created and the column on which, the column in which the where condition is using should be same. So if where condition is using a different column and the indexable column is a different one, then Oracle can never match or Oracle can never use the index. For example, let's say you have a topic with some name ABC, and you are searching for XYZ. So in your index, the name was there as ABC, but you are searching as XYZ. Then what happens? You will never get that particular information, and you need to again scan entire book in order to know where is XYZ. So similarly here also, the department number is the one which you are using in where condition, but the index got created on EMP number. So in this situation also, Oracle will never make use of index, and that is the reason it is going for full table scan. So one important point you need to remember is the column on which the index got created and the column which you are using in where condition should be same. For example, I am taking another case, and this time I am showing a different query. So now this time you can see it is clearly using the index which is there on the table, that is pk underscore emp. So why it is using the index this time? Because the column on which index got created and the column which I am using the where condition are one and same. That means if in the book index I have the chapter name as ABC and I am searching with the term ABC, then I could able to get that easily. But if the book index is having the name as ABC and I am searching for XYZ, I will never get that XYZ. So this is very important point that you need to remember. The column on which the index got created and the column on which the where condition was there, both should match. So is this point clear with everyone? Anyone is having queries, please let me know. Okay. So that is all about to identify whether our query is using indexes or not. So basically, explain plan is going to help you to identify whether your query is using indexes or not. But here what we did is we just understood a point that the column both the columns should match. But let's say my application team says strictly I want to use this query only. So they say that, boss, because you said something that the columns are not matching, I can't change my query because queries will be written based on business logic. And now you can't go back to your client and say that, we can't proceed with this column. Instead, we need to use this column. You can't say that. So for example, it is something like this. Let's say you want to retrieve the information of savings account in a bank, but bank people are saying you can't retrieve savings account. Instead, you can use retrieve current account. Suppose if you don't have a current account at all, then why will be using current account column at all? So it is something like that. If application team is strictly saying that we want the column as DPT number only, then what we need to do? We need to go and create a new index on DPT number. So for example, we have the syntax for creating an index. Let's say I'm creating a new index like this. So I'm creating an index with the name DEPT IDX on EMP number and on the column DEPT number. And now if I say explain plan for this particular select query, and then if I retrieve the explain plan for this, then it should show me the new index which I got created. And now you can see here. Earlier, because on DPT number there is no index, it is going for full table scan. But now you can see it is going for this particular index which I have created. So that means if at all index is not there in on the column which you are using, then you need to create one index on top of that. So here the sixth point is going to talk about the same. If index is not there on the table, create an index on a column which is after where condition in the query. Now one thing we need to understand here is what type of index we need to create. Okay, creating an index is fine, that is a simple command, but what type of indexes we need to create? So for that we need to know how many types of indexes are there, I know what is their storage mechanism, all those things. So we have totally, in point number 7 you can see, we have totally 4 types of index. One is B-tree index, second one is bitmap index, third one is function based index, and fourth one is reverse key index. So out of 4, the first 2 are very important, and the function based index and reverse key index will be used very rarely. So we don't require too much concentrate on that. So first let us go and talk about the B-tree index. So when you have B-tree index in place, it is going to store the index data in the form of tree structure. So let me show you that how the data is being stored in B-tree index. So this is how the index values will be stored, or more of a kind. Let me take another example. Okay, so this is one example. So actually what happens in storing B-tree index is, whatever the total number of row count you have, those many the row count will be divided by 2, and whatever the mid value that would be getting, that mid value we will be placing at top. For example, here you can see there is a table assumed with the 35 rows. So when you split 35 rows by 2, then you would be getting somewhere around 14 point, or not 14, so 17 point something. So because we could not take that 0.5s or something like that into consideration, so you would be, Oracle is going to adjust that value. Here in this example it has adjusted to some value like 13. And what happens is, all the values which are less than 13 will be falling on the left hand side of the index, or left hand side of that root value. and all the values which are greater than 13 will be falling on the right hand side. So again, if you go for it, you have 1 to 13, and out of 1 to 13 you will be having mid values, and again the same similar distribution will be handled. So like this, basically the index data is going to be distributed in a tree format. Suppose here you want to search for a record which is of 10, let's say value of 10. Then what happens is, first that 10 will be searched with this 13 value. Something like is 10 equals to 13. So definitely 10 is not equals to 13. Then it will identify is 10 less than 13. Yes. So when 10 is less than 13, it will fall on the left hand side, and then it will verify is 10 is greater than 4. Yes, it is greater than 4. Is 10 is greater than 7. Yes, it is greater than 7. Then it will come down to these three values 8, 10, 11, and then it will verify is 10 is greater than is 10 is greater than 8. Then yes, 10 is definitely greater than 8, and then it is going to verify is 10 is greater than 10. No. Is 10 equals to 10? Yes. That means 1, 2, 3, 4, 5. So in 5 searches you will get your row immediately. But rather than that, if you want to go for full table scan, then you need to retrieve or you need to scan all the 10 rows or all the 35 rows. So this is what basically index is going to help you, or B3 index is going to help you. So is this point clear with everyone? So if you have any questions, let me know. Okay. So what Oracle recommends is you need to create B3 index whenever you have more number of distinct values in the column, like primary keys, unique keys. So when you have these primary keys, unique keys and all, you need to create B3 index on top of them. And apart from B3 index, as I said, we have another type of index, that is bitmap index. So see how bitmap index is going to store the data. So this is one example where you can see it is going to, bitmap index is going to store the data. I hope this is not visible. Is this visible to you guys, this diagram? And let me save to it. Okay, fine. Is this visible now? Okay. So basically, bitmap index you need to create for the type of indexes which are having very less number of distinct values, like gender column. Gender column we usually will have only two distinct values, male or female. Or location, you will be having small number of values. So whenever you have a very less number of distinct values, then you need to go for this. For example, in this diagram, you can see basically it is storing something called a hair color, and there are hardly very less distinct values like brown, red, black, and blondie. So there are only four distinct values that we have. So how this data is being stored, you can see here. For each row ID, if for row ID 1, the hair color is brown, then at brown it is going to mark as 1, and for black, blondie, and red it is going to mark it as 0. So that means wherever the row ID hair color is matching, there it is marking it as 1, and the rest of the other values it is marking it as 0. So 0 and 1 we usually call it as bitmap values. So using those bitmap values, it is going to store the data in this tabular format. So as I said, this bitmap index you need to use whenever you have less number of distinct values. So that is what basically B3 and bitmap index is. And as I said, function based and reverse key index we are not going to use in real time, so we can just ignore them. So what is our target is, after generating explain plan, we need to identify whether our query is using indexes or not. If it is not using indexes, then we need to create the right type of index. As I said, if the column is having more number of distinct values, you need to use B3 index. And if at all you want to, your column is having really less number of values, you need to create bitmap index. And even after doing all these, let's say the performance of the query has not improved, then you need to as a next step, you need to verify first of all whether whatever the table you are having, is the table is perfect or not, or is the table is the right type of table or not. So for that, we need to understand what are all the types of tables that are available. The first type of table which is mentioned in point number 9 is general table. So general table is the one which we regularly use, which is divided into rows and columns and all. And the second type of table that we have is cluster table. So basically cluster table is used to have the space advantage. For example, let's assume there are two tables A and B, and both of the tables are having a column called X. So let's say A is also having X and B is also having X. And in A also X is having same data and B also X is having same data. Then what Oracle thought is, anyway A and B are having the same column as X and even the data is also same, then why I need to store this X two times, one in A and one in B. Rather, I can store X in a common location and I can ask A and B to share that column in between. So this will reduce or this will save some space without storing the same data twice. So that means basically you are avoiding duplication. So that is how you have whenever two tables are sharing the same column, you will be calling it as a cluster table. So here in the diagram you can see A and B are sharing common column X. So we can say both A as a cluster table and B also as a cluster table. But the disadvantage with the cluster table is, if at all A wants to modify X or B wants to modify X, it is not possible. So usually this cluster table concept should be used for static tables. So if both A and B are static tables, that means data is not getting modified every time, then we need to create those tables as cluster tables. But the usage of cluster tables in real time is very rare case because of practical complications, and as I said, modifications to the column will not be happening when it is in a cluster. So all those headaches are there. So that's the reason you will not be seeing this usage in real time. And the next type of table that we have is index organizer table. So here index organizer table is something like what Oracle thought is instead of having index separately and table data separately, why can't we have the table itself in index format? So that means in tree format. So instead of having index separately and table separately, we can have the table itself in index format like in the tree structure. So you can see over here there is a diagram which displays what is the difference between the regular table and the index organizer table. So here you can see in regular table first index is there, and by having a scan of index and the row IDs, then finally the data is being retrieved from the table. But whereas in index organizer table, the table data itself is stored in the index format, that is in the tree format. So this will improve the performance of the searching of queries. But again, the problem here is whenever you want to perform some DML operation or DDL operation on this table, it is going to take much time. Why? Because suppose you are deleting 1000 rows from index organizer table, then when you delete 1000 rows, the mid value will change, and when the mid value changes, the other values also will get impacted. So that is the reason. Usually, again, this index organizer table should be preferred either for static or semi-dynamic tables. If the data inside the table is updating or deleting or inserting frequently, then you should not declare the table as index organizer table. So that is the disadvantage that we have. And the next one we have, or the final one we have, is partition table. Normally, let's say you want some data to be retrieved, and you have a very large database, then obviously to retrieve the data from this very large database is going to take some time. But rather, if you specify that I want the data to be retrieved only in a particular partition, then it is going to give you some advantage, or it is going to give you uh, the response time will be improved a lot. So I'm just going to show you how a partition table is going to look like. So if you look at a diagram here, it is going to explain about non-partition and partition tables. Let me show you that. So I hope you people can see on the screen. On the left hand side you have a non-partition table, and on the right hand side you have a partition table. So usually partition tables will be created whenever you have very large tables, and the Oracle recommendation is if the table size is more than 2 GB, then you need to create them as partition tables. So the advantage is on the left hand side, if you have a look, your complete table data is being stored in a same location, or as a single component. But whereas on the right hand side, if you have a look, the January data has been separated, February data has been separated, and the March data has been separated. So whenever you have this data separated in months or any other format, and suppose you want to retrieve the data only in February, then you don't require to touch January and March components here, or January and March partitions. Directly you can go to February and you can retrieve the data from the particular partition. So by this, your search time is going to reduce a lot. So in earlier case it is not the one. So even though you want to have February data, you need to scan through January, then February, all those things. So this is one advantage that we have with partition table. And if at all already a table is existing, how we need to do partitioning is we need to create an empty partition table, and we need to insert the data from the original table to the partition table. For example, let us say I have EMP table, employees table, and I have decided to partition that particular employees table based on the date of joining. So what I say, or what I can say is something like the employees who joined between 1990 to 1995. So for 5 years, so that data should go to partition 1. And the employees who joined between 95 to 2000, it should go to partition 2. Employees who joined between 2000 to 2005 should go to partition 3. Then 2005 to 10 to partition 4. So 10 to 15 to partition 5. So I can declare some syntax like this. So whenever you are partitioning with the help of a date or a number data type, we usually call it as range partitioning. So range in the sense from this value to this value you are doing the partitioning. So that is one type of partitioning available. And whenever you want to divide your table based on the values, the character data type, then you are going to do the list partitioning. For example, let's say you want to divide employees table based on the locations. Like partition 1 should contain employees belongs to Bangalore location. Partition 2 should contain employees belongs to Hyderabad location. So if you want to divide like this based on the character values, then you would be going for list partitioning. And the third one you have is hash partitioning. If at all you are using hash functions in the table, then you can make use of this hash partitioning. But in real time, it is very rare case that you will be seeing hash partitioning. So most of the times you will be seeing range partitioning and list partitioning. Now Oracle has given you one more flexibility that if you feel that the original partition is very large, you can still divide that into sub partitions. So for that we have different types available. Like you can see in point number D, range partition is available, range list is available. So when you say range, that means your main partition is range and your sub partition is also range. And when you say range list, your main partition is range and sub partition is list, something like that. So you have different levels of partitioning implemented. And as I said, if you have already a table and you want to do the partitioning, you need to first create an empty partition table and you need to insert the data inside it. So I have a sample script in my blog. Let me open and show you that. So this is the script, in my first project when I use it to work, I have used this particular script. So it is basically for birth registrations. So whenever a child is born, you need to get the registration done in corresponding municipality or wherever it is. So basically this table is for that. So we have so many columns as you can see here. So these are all the columns that we have. So what we have is we used to have some performance issue on this particular table, and when I checked, the table size is 3.2 GB and it used to have nearly 50 lakh rows. So what I have done is I have created one empty partition table using this particular script. So here if you have a look, what are all the things I am using is, I am basically using partition by range and on the column date of birth. So on date of birth column, I am doing partitioning, and how I am doing that partitioning, you can have a look here. Totally I have created 16 partitions, and each partition is having its own restriction. Like partition P1, that is the name of the partition. So P1 should contain the birth date less than 1st Jan 1960. So from the oldest date till 1st Jan 1960, we need to have the partition, we need to have the data in partition P1. And in partition P2, we need to have the data from 1960 to 1965. That means 5 years of data. Like the same way, in P3, we need to have from 65 to 70. So then 70 to 75, 80, 85. So we went till that time. And in partition 7, instead of taking 5 years, now I have taken only 3 years. Why? Because, you know, the birth registration awareness has been increased from 80s onwards, and we used to have so many registrations done. So that means in these years, 85, so from the beginning of 85, the number of birth registrations are very huge, and data is also very more in my table. So that's the reason, instead of taking 5 years span, I just reduced that to 3 years span. So like this, I continue till 2015. So the last partition, if you have a look, it says partition P16 values less than to date of 1st Jan 2015. So that means for future also I have created the partitions and made it ready. So this is one advantage that we want. And suppose now if you want to search for a particular person who is having a birth record of 1995, let's say, then what happens is Oracle will straight away jump to partition 10, because partition 10 contains 3 years, 95, 96 and 97. So it will not touch the other 15 partitions. Straight away it will go to partition 10 and it is going to retrieve the data. So this will definitely improve the performance of the select queries. And one more thing what Oracle recommends is, whenever you have partition tables, you need to have partition indexes also. And for that also I have given a script below. So where you are going to, create the partitions, index partitions. So that is how we have partition table in place. And still after, we decide on the type of the table and all, if we feel that, the select query performance has not been improved, then we need to look into the next phase. So that is database level tuning. So whatever we are doing till now is object level tuning. So now we need to move ahead and do database level tuning. So we will see this database tuning tomorrow. So before we close today's session, anyone is having any queries regarding this partition table and all, just let me know. Yes, for very big size tables, we would be generally creating the partitions. Like for example, in bank, let's suppose there is a bank and it want to store the customer information. Like every month customers doing their transactions. So what they do is, January they will create one partition, February they will create one partition. Like this they will create 12 partitions for a year. So usually Oracle's recommendation is, if your table size is more than 2 GB, then you need to think of doing the partitioning. Till 2 GB it is not required to do partitioning, but more than 2 GB you require partitioning. So any more queries from anyone? I didn't get you, Sanjay. What you mean by how to know the update? Do you mean to say how to tune update statement? I'm not getting your question. Are you talking about gathering the statistics? Okay, just a minute. I'm getting a call. Sorry guys, yeah. Okay, regarding your first question, Sanjay, like how to find whether the table statistics are up to date or not, we have a select query. In the beginning itself, I showed you that. This is the one. In page number 88, you have that. This is the select query. So this will give you the date on which, the last analysis was done. For example, if let's say executed here. Okay. And so you can see it is giving the date here. So if you compare that with today's date, it is showing you yesterday's date. That means it was not updated to the latest. Then you have commands in page number 89 and all, so you can use those commands and you can update the statistics manually. And regarding the second question, we cannot exactly understand whether there is any change in the code and all, because we don't have access to application code. So we need to just drop an email to our application team, or in the call if there is any conference call going on. So in the conference call we need to ask them if they have done any changes. Apart from that, we can't actually check anything from our side. So any more queries from anyone? Okay. So the problem is that it is already saying in the last error that file is existing. So what you do is just remove that control file which is showing above, like U01 app Oracle. So in that path you have that control underscore 01.ctl. So remove those all the control files. If you have created two or three, remove all the control files and then try manual creation. It will work. Okay. So thanks everyone for joining the call. So tomorrow we will work on the database shooting and the rest of the topics. So till then, have a nice day and good night.